in this section, we'll cover how data was transferred before networks came into picture, what a network interface card is, RJ45 male and female connectors, the concept of source and destination addresses. We'll introduce MAC address, defining the structure of a frame. So imagine a world before networks came into picture. We had a user Alice and Bob. Alice would work on a laptop, do some data processing, Word or Excel, store the data on her laptop, and anytime she had to share the information or data with Bob, she would copy it on a floppy disk and then walk over to across the office to Bob and hand it over floppy to Bob. Now, back in the days, we didn't have the USB drives. It was the floppy drive that we used. So this was a cumbersome, repetitive process and inefficient. Every time she had to walk over and pass the information on the floppy disk to Bob. Okay. So moving forward, somebody had an idea and decided to connect the two computers with a wire, right? Form a network. Okay. And then whatever data, anytime Alice had to share with Bob, that could be transferred without going across the office, sitting at her place. She could just transfer it using the network over the wire. And that's how Bob would get the data. Efficient, right? Now, previously, before the network came into picture, this was what we could think about the structure of a computer. It had a motherboard, it had a CPU, hard disk, RAM, and then anytime when the networks decided to come up, another entity came into picture, which is called as a NIC, or the network interface card. Network interface card. Now, expanding this further, how would these two computers communicate? What would be the different elements? So this would be a NIC card. Now, in the NIC card, you would have a RJ45 connector. To be more precise, on the NIC card, an RJ45 female connector would go. And then you would have a cable, and at the end of the cable, you would have a RJ45 male connector. Okay. And then if you have to picturize this completely, this is how it would look like. Alice and Bob have their desktop laptops. As we just mentioned, it would have a NIC card, and in the NIC card, you would have the RJ45 female connectors. And then in these connectors, you would have this cable with, this is the cable, and with RJ45 male connectors on both sides. And then these would go and connect or fit into the RJ45 female connector. Okay. So this was the physical structure, how the two computers would get connected. Now let's move on to the concept of addresses. Now, before we go into the concept of how source and destination addresses are used in computer networks, we would draw a parallel or draw an analogy of how, if one person, right, how a letter is transported from one person to another. So suppose, again, we have the user Alice and Bob, and suppose Alice wants to send a letter to Bob. Okay, so she would take a paper, write a message on it, right? Hello, Bob. I hope you are doing fine. I'll arrive on the 20th. Regards, Alice. So this is what she puts in the letter. And then next, what she does is she takes an envelope, right? And then envelope is open, and then put her letter in the envelope and close the envelope. Okay. Next is on the front side, she would put Bob's details. For example, to Bob, because she's sending it to Bob, and then followed by Bob's address. Okay. And then she would flip it around And on the rear side or the back side, she would put her own details. For example, from Alice and Alice's address. Okay. And then, of course, this will be mailed or sent out. Now, what do we extract from here is the concept of source and destination address. Now here, Bob is the receiver because it is being sent to Bob. Receiver's address, this is what in terminology, in computer terminology, we'll call it as the destination address. Or in short form, we'll call it DA, but this is destination address. Likewise, for Alice's address, it is the sender's address and it becomes the source address. So the key concept here, the takeaway from here is the destination address and source address. Now let's apply, let's see, we have drawn this analogy that, how address are used when the communication of letter between two people. Now let's try to, extrapolate this into how these would work in computer networks. Now, just like Alice had an address and Bob had his address, similarly, in computer networks, each NIC card has an address. This address is known as a MAC address. Right? Remember, Alice had a computer, Bob had his computer, and both the computers have their NIC cards. So what we are saying is each NIC card has a MAC address. Okay. MAC address for any NIC is unique. No two computers in the world can have a NIC card that has the same address. Okay. MAC address is also known as L2 address. Why L2 address? Because MAC addresses operate at the layer 2 layer of the OSI model, which is the data link layer. So that's why it is also interchangeably used as MAC address or layer 2 address. Okay, finally, let's go into start building the concept of frame. So anytime a person wants to send data in terms of sending a letter, they use an envelope. Similarly, anytime a PC needs to send data to another PC, it needs to create a frame. Create a frame, and then in the frame, it would send the data. Okay, so let me elaborate further. So we have a PC here, PC1. Okay, I may use these terms interchangeably, PC, host, computer, desktop, laptop, but they all mean the same thing. So just follow along and excuse me using these terms loosely. Okay, so we have PC1 and PC2. Okay, they are connected using a wire, a cable. Okay, obviously PC1 would have a NIC card, PC2 has a NIC card. I am not telling the details here. And then what we can understand is this PC1 has a MAC address A. What this means is this PC1 has a NIC card which has a MAC address, which is, for example, in a simple terms, I'm using at A. Similarly, this PC2 has a NIC card which is having a MAC address B. So I can say PC1's MAC address is A, PC2 MAC address is B. So what goes in the frame? Right? Destination address. Just like in envelope, we had on the front side, we had put to address, receiver's address, and on the rear side, we had put the sender's address, and inside the envelope, we had put data. Similarly, the concept of frame is there. So in the frame, we have one field which is called destination address, DA. Then there is SA, source address, and then there's data. Of course, there are a couple of other fields also like type and checksum, but to keep the topic discussion simple, I'm going to ignore and park these for the time being, and we will cover this later in the later sections. Okay. Now, let's take an example. So this is what the construct I'm saying is the frame. DA, it has a field by DA, SA, and data. Now let's see if we are to send data from PC2 to PC1, from PC2 to PC1. what will be the values of DA, SA, and data, right? Again, the direction of data flow is from PC2 to PC1. PC2's MAC address is B, PC1's MAC address is A. Okay, let's see. So this is the direction of the flow. Now, what is the value of DA? Destination address. PC2 wants to send to PC1. So destination address has to be A, right? So we put it as A. And since PC2 is sending it, this is a source address. It will put its own address B in here. B. Source address has to be B. And then, of course, data is data. Okay. Now this was the case from PC2 to PC1. Let's take it further, go a little bit more in detail and see how does the data transfer take place from PC1 to PC2 step by step. Okay. Up till now, what example I took was from PC2 to PC1. Now we have reversed it. The data transfer has to happen from PC1 to PC2. Okay. PC1 wants to send data to PC2. Okay. Direction is it creates a frame, right? And so this is the DA, destination address, source address, and data. So obviously PC1 wants to send it to PC2, so destination address has to be B. And source address has to be its own address because it is the sender. Source address has to be A. And then it sends the data and put the data and then sends it across like this in this direction from PC1 to PC2. And this is frame is sent over. Okay. Next, now PC2 receives the frame. Now here's the key concept, another key concept, right? Checking whether the frame belongs to me. It has received the frame because it is simply connected. Now it has to check whether the frame contains data for it or not. Okay. How does it do that? PC2 receives the frame. It checks the value of the DA field, destination address field. What is the value in the destination address field? It says B. What does it signify? It says that it is for this frame is for a computer whose MAC address is B. Okay, that is what it means. So when the PC2 checks the destination address field of the frame, it finds it to be B. Okay, next, find it to be B. Next, it compares it with its own address. It has found it to be B. It checks what is its own address, and it finds it to be again B. So does it match? Yes, it did. It does match. So hence PC2 knows that yes, since my own address matches with the destination address of the frame, of the envelope, it is intended for me. Hence, I can accept it. If it had not matched, it would have dropped it or rejected it. Okay. So this is what is the important aspects that I wanted to cover in this lesson. Summary point for this lesson. NIC card stands for network interface card. NIC card has RJ45 female connector, and there is a cable that gets connected to the RJ45 female connector. That cable has RJ45 male connectors on both ends. I'm deliberately not mentioning this is the Ethernet wire, Ethernet cable. This will be covered later. Want to keep the discussion simple and develop the foundation and concepts gradually. Okay. Next. And then each NIC card has an address. This is called as the MAC address. No two NICs in the world can have same MAC address. And then finally, till now we have covered the concept of destination address, source address, and data fields of the frame. Okay, as I mentioned, there are other fields also in the frame like type and checksum. These will be covered later in the later sections. For now, just focus on destination address, source address, and data fields. Okay. In the next lesson, we will expand our discussions to a little bit more complicated networks, where instead of two computers or two laptops or desktops, we will make the communication or connection between three PCs, PC1, PC2, PC3, and we will also introduce the concept of hub and how does it operate.